So let us define a probability distribution. Let x be a random variable corresponding to some random experiment. Now let range of x be equal to some x1 comma x2 comma so on xn. This is range of x. We have said that a random variable is a function from the sample space to real number set, wherein to each sample point it attaches some real number based on certain rule. Now, what does a probability distribution mean? Corresponding to a random variable, you have a range of the random variable. Now, probability distribution is a function p from the range of the random variable to 0 comma 1. That is, to each xi some number pi is attached such that pi lies between 0 and 1. So, and some of the probabilities, some of these pi's, I ranging from 1 to n, is equal to 1. Now, we observe that this 1, which is equal to probability of sample space, is getting distributed among different n numbers. What is P1? P of x1. Now this we call as a probability distribution. Here this P of xi is actually probability that the random variable x takes a value xi. So how do I attach this number P of xi or pi? It is the probability that x takes a random variable xi. Let us illustrate through an example. For example, you have the random experiment of tossing a pair of coins. Tossing a pair of coins. Sample space is, we know, HH, HT, TH, TT. Now let us think that x is the number of, x counts, x is a random variable which counts the number of heads. Counting number of heads. Number of heads. So what is the range of this random variable in this context? Let me write this here. Range of the random variable is 0, 1, 2. So for this example, range of the random variable is 0, 1, 2. Okay. Now what are all the sample points which are getting mapped to 0? It's tail head here. Tail, this both coins showing tails will give the out number as 0. Then head, tail, tail, head. For both these outcomes, the number attached is 1. For head comma head, the number attached is 2. Now, what are all the sample points which are getting mapped to 0? This is the only sample point. Okay, so when I say probability that x takes a value 0 will mean what are all the sample points which are mapped by x to 0. That is, it is going to be probability of the event corresponding to, that is, what's the event? Probability of, what is an event? Event is a subset of the sample space. So probability of the event corresponding to x of omega equal to 0. So what are all the sample points which are mapped to this? So t comma t is only sample point. So then I would have got probability of t comma t. And that is of course 1 out of 4. Similarly, probability of x equal to 1. How many sample points are getting mapped to 1? 2 of them. So it will be 2 out of 4. What is the probability of x equal to 2? That is 1 out of 4. That is, what is x? Random variable which counts the number of heads. Which are all the outcomes which give the 2 heads? H comma h is the only outcome which gives that. So out of 4 outcomes, 1 is favorable to getting the random variable value of x as 2. So the probability that x equal to 2 will be 1 out of 4. So now this gives us a distribution here. We observe that there is a distribution. This is x values 0, 1, 2, p of x, probability of x equal to small x. These are x small x values. What is that? 1 by 4 here, 2 by 4 here, and 1 by 4. If you add up all this, the sum is 1. Okay, that's what we said. Probability distribution is like a function from the range of random variables to 0, 1 set, wherein to each value of the random variable, that is to each one value of the point in the range of the random variable, we are attaching some number, and that number will be actually probability that that random variable takes that particular number. And if you add up all these probabilities, we should be getting it to be 1. That is, the probability of the sample space which is equal to 1 is getting distributed among different values of the random variable here. Let us talk about a theoretical probability distribution. Now previously I have given an example of a probability distribution that arose out of a random variable which was in a practical situation wherein we have tossed a pair of coins and random variable was to count the number of heads in that each outcome. Corresponding to that we gave a probability distribution. Now we can write some random variable, let x be some random variable corresponding to some random experiment. Now the range of x, some x1, range of x is some x1 comma x2 comma xn. Now corresponding to each value of the random variable, you can attach some numbers p1, p2, so on pn, so that all these pi's are non-negative and sum of these pi's is equal to 1. Sigma I ranging from 1 to n, pi is equal to 1. Now this way of attaching to some values of random variable, you need not even specify the type of the random variable. So you just give the values of the random variable, and to corresponding to each value of the random variable, we think of some rule of splitting the probability of the sample space which is equal to 1 among different values of this random variable, so that some non-negative values are attached to each of these values of the random variable so that the sum is equal to 1. For example, I have something minus 1, 1, 0, 1 are the values of some random variable corresponding to some random experiment. I attach some numbers p of x's. Probability or pi, this is x1, this is p1. I can give some number 1 by 4, 1 by 4, and let's say 2 by 6 and 1 by 6. See, sum of all this is clearly 1. Sigma of this pi's, this is p1, p2, p3 and p4. Sigma of this pi's is equal to 1, and we are attaching non-negative values to each value of the random variable. Random variable can have a negative value. Random variable can be, value of a random variable can be any real number, but probability cannot be negative. So what we have assigned here is to each value of the random variable we attach the probability that that random variable takes that particular value. So 1 by 4, 1 by 4, I have given this. You may just, this is one x1 random variable and a probability distribution corresponding to this random variable. I can write some other random variable, some other range of random variables, say 0, 1, 2, 3, and I have probabilities 1 by 4, 1 by 4, 1 by 4 like this. Okay, or I can even change these numbers. Let's say I have this is say 1 by 2, and let us say this is made 0. This is made 0. Now the only thing that we have to ensure is that the sum of all these have to be this 1 and all these numbers have to be non-negative. So this way we can generate any number of probability distributions by just writing some values of x's and corresponding to them you attach some non-negative numbers whose sum will be equal to 1.